Okay, early to it. Thanks for the reply. I think it's true that we can find models that can solve problems, and I would say those problems are about the real world. But what defines the real world? Ultimately, what defines the real world? Okay, it's a word, but what defines it in terms of a concept? How can we build a definition, an answer to what is the real world? And the only way is through our perceptions. And as you said, our perceptions are, not. There's issues with our perceptions relating to truth or transmitting truth. But see, you said that they were filters, and you assume that they're filters. We believe they're filters. We believe that there's things going on in the real world. This is our model of materialism. We have a model in our head of the real material world, you would call. And we believe that there's stuff going on out there. And that stuff sometimes impacts our senses. Light strikes our eye. And so we see our senses as transmitting. But that's an assumption because, cognitively, just from inside our mind, what perceptions are a source. They're a source. It's like a spring springing up out of the ground. We don't really know where the spring comes from. We can't prove it. Now we can make a theory that it's a big underground aquifer because there's water and we believe in continuity. We believe in the principle of continuity. So whatever, we see the spring, we know, well, it's water coming out of the ground, so there must be water under there coming up as well. We believe in the continuity. But we really don't, know epistemologically. We can't prove that. So when you make a model that solves some problem or figures everything out, what you're figuring out is about perception. It's about the water after it comes out of the spring and what happens to it then. We know at that point here this is water and it has certain properties, and we know our perceptions have certain properties. And a good theory about so-called reality is tested by adhering not with reality but with these perceptions after they've come out of the well. We say, well, look, at this theory would explain where these could come from. Now the issue is that even if you had a perfect model, let's say reality is just numbers and a number crunching, and so that if you put a couple numbers, I just use this example, if you put a couple numbers into this black box, one number comes out. And you study the patterns between the input and output numbers until you realize that you have a mathematical equation that will always figure them out. That's like if we figure out a model of reality that was always accurate about the real world. And we don't have anything like that, but we have things that are pretty accurate about an amazingly large number of things. Okay, well, in the case of this black box, let's say we figure out the equation and it's x squared minus y squared. The two inputs are x and y. Okay, the thing is, we would still not know that inside that box that something is taking x and multiplying it by itself, which is what x squared means, and same with y squared, and then subtracting them. That method implied by that formula, the method that you would do if you're just reading the formula and plugging things in and calculating it out, we don't know that's really going on inside the black box because there's other mathematical equations, x minus y, times x plus y. Same numbers will come out of that. But the method, if you're plugging things in and calculating that, is still different. It takes a different amount of time. There's things that are different about it. And yet you couldn't necessarily know that, even if you had a perfect mathematical model. Now the other issue is just take this theory of materialism. We know that there's all this stuff out there. There's just a tremendous amount of stuff out there. It might as well be infinite for now, compared to us, even if it's not literally infinite. And it might be literally infinite. So we cannot really, we're just a tiny little subset. So we know we can't model the whole thing because that would require us having in our minds as many details as are in the whole world. But our minds are a part of the real world. Our mind is some of the details of the world. So yeah, we can't even get a good conception of our own mind because to have a perfect conception of our own mind would require too many details. Models are, if you look at them again in a practical sense, are, intentionally lack detail. A model is something you can use to make a calculation. If you took in too many details, you wouldn't make the calculation. Instead, you take a just partially accurate approximate model. It gives you an approximate number, and that's fine. You can know how approximate it is. And you can know that, okay, to land this plane, this number has to be accurate to within, 3 inches. And if you then do your approximation so that it's accurate to within 1 inch, you're fine. And that's how everything works, all knowledge, within tolerances. So now, I don't disagree with the idea that you ought to be able to get a mathematical equation to explain it. Maybe. I'm not sure. That's an interesting subject. But I'll grant that in this argument, that's possible. And yet, that still wouldn't be reality. That would just be a model, an equation you had that matched reality really well. Okay? It wouldn't mean that in reality, the same thing was going on that you suppose is going on. Because all you can really know is that it would be functionally equivalent to what's really going on. Okay? And that would be a practical thing. See, it would be a very useful equation to have because it always got the right answer about reality. But it still wouldn't mean that it was going on in reality because some other process that was functionally equivalent that produced the same results could be going on. And that's why the matrix argument is, even though we all pretty much assume, no, that's not going on, we can never prove that because it's designed, it's a philosophical idea designed to be functionally equivalent to the real world, no matter what the real world is. It's like, instead of it being whatever you think, it's a computer generating that image. And because of the way imagery works, and because we are modeling, there's no escaping that. It's because the senses, I believe the senses are transmitting information about our surrounding world. And it's because I believe in this principle of continuity. But it is possible that we're just minds in a computer because in reality, the perceptions are just the source. And they're all mixed. We don't even know our perceptions are coming from the senses. We look up in the sky and see a cloud with a face in it. It's like sense perceptions mixed with imaginary perceptions by the time we're looking at them. And you really have to dig and look deeply. And we never know which ones are really coming from the senses, except for one. Sense perceptions are loud and can be made loud, right? Like if you're having a dream perception, a sense perception, you can sort of really look at the thing, and your sense perception has a better chance of being amplified. Excuse me. And then the other thing is that the sense perceptions are consistent. They follow the laws of continuity. And totally imaginary perceptions don't. So with that knowledge of the difference, that's how we pick out the sense perceptions, and they're still lacking. They're not 100% accurate. They're just little readings, and we have to be like Sherlock Holmes. We do it all in an instant and deduce all these 3D information and everything we know around us. So anyway, the main point is that even if you had a perfect mathematical model, all you would know is that it is functionally equivalent to the process that's going on in reality. And that's all I'm saying. So you can have a system just as useful as if it were the real thing, but you can never actually know if it is the real thing. But, we'd be happy with the theory of physics that was just good enough to be functionally equivalent. I personally don't think it's possible to have a model that's functionally equivalent. I think they can only functionally approximate it. It's like with a Maclaurin series or a Fourier transform. You can approximate with a finite number of terms. You can approximate any other curve, but not for infinity. Okay, only certain ones can be, modeled for infinity, and in reality there always be patterns. They can't be modeled for infinity that you cannot match for infinity. And for example, the formula for pi, the numbers of pi, how the numbers come out of pi, the sequence of digits in pi, you can approximate that with the Maclaurin series for any arbitrary amount of distance, but you can't do the whole thing. And that's what the deal is with transcendental numbers and QM and uncertainty principles. That's what we're learning. Barely made it.